So I was given, I was sent a send to instructor button push by a student that asked about this question. You're asked to solve this logarithmic equation. And I can guess already where the hitch is and why this is being marked incorrect, but we'll see how it goes. I have not done it out yet. I'm doing it on the fly. So first, we see these two logarithmic terms, and they're separated by this minus sign. So that should bring to mind this idea. The logarithm of x over y can be rewritten because it is equal to the logarithm of x minus the logarithm of y. So this is one of the properties, or I call them shortcuts because they stem from shortcuts in exponents, excuse me. And so I'm going to deploy this, and so the insides of these two, this will act as x, this will act as y, such that I can rewrite the left-hand side of my equation to be log base 2 of x minus 3, the numerator, divided by x plus 3, the denominator, and that's going to be equal to 3. Now, there's a number of ways to go here. We could do a number of things. For instance, we could rewrite this in exponential form. If we did that, 2 is our base. 3 would have been the exponent that we solved for. Imagine if it was a variable. That was I don't think it was the sole purpose, but you can think of logarithm. Its sole purpose was to solve for the exponent. So there it is, solved for. But we're going in the other direction and removing the logarithm, going to exponential form. So the 3 becomes the exponent on the base of 2. And I'm left with x minus 3 divided by x plus 3 on the right-hand side. So that's one way to get there. Another way to get there, I think, is probably more popular with mathematicians. We would just raise this left-hand side to the base of 2 and raise this 3 as an exponent on 2. You'll end up getting the same thing. On the right-hand side, we get 2 to the 3. On the left-hand side, because these are inverse functions, they would nullify. I don't like using the word cancel because it's not very mathematical, but they undo each other because they're inverse functions. So I'm left with x minus 3 over x plus 3. And so we get the same thing. Now, as I've said to many students when trying to wrestle with this, I try to get them to think about, I do not like it when variables are in the denominator because it messes everything up. So that tries to inform you regarding what next step you should take in solving for our variable x. So I'm going to multiply this side by x plus 3. Why? Because these equal 1. If I do that on the left, I must also do that on the right. And so I get with x minus 3 on the left-hand side, and I get 2 cubed, which, by the way, is 8. So let's just make it an 8 times x plus 3. Now this becomes a much more straightforward linear equation where I have x minus 3 equals 8x plus 3 times 8 is 24. I distribute the 8. And now I'm going to subtract x from both sides and get negative 3 equals 7x plus 24. And then I'm going to subtract 24 from both sides and get negative 27 equals 7x. And unfortunately, this does not result in an integer, which is good in some sense because we're maybe too used to things becoming resulting in integer answers. But I get this, not irrational, oh my goodness, improper fraction, which is fine, negative 27 sevenths. Now, what we need to do, I mean, you could stop here and say that's the solution, but we might want to change this to a mixed number. I very infrequently do this, but it might be helpful for in this particular situation. So 7 divides into 27 3 times with some leftover, right? So 21 6 sevenths. 3 and 6, negative 3 and 6 sevenths. And the reason why I need to do that is I'm trying to see where this is on the number line a little much more clearly. And it's because I have to go back with logarithmic functions because my original function was not this linear function. It was this, the linear equation. It was this logarithmic equation. And there are restrictions on the values that x can take. There are restrictions on the values that x can take. There are 2 restrictions. So first of all, remember that the logarithm as a function has a restricted domain of 0 to infinity. I had a student just do a presentation, and he did a nice job. This is the exponential function y equals, or f of x equals let's say 10 to the x, since I'm working with log. And its inverse is this function, y equals log base 10 of x. Oops, why did I write 10 there? Which we simply write log x for lazy purposes. So they're inverse functions. If this is an asymptote for the exponential function, y equals 0, then that becomes, when we invert it, becomes the vertical asymptote, x equals 0. So my logarithmic function does not go to the left of x equals 0 and does not include x equals 0. So its domain goes from 0 and as far right as we possibly can go towards infinity. So that domain restriction means that each of the, quote, insides or argument for these logarithms must be greater than 0. So x minus 3 must be greater than 0. And x plus 3 must also be greater than 0. So this is how we can figure out what x values our original equation can take. So I'm going to add 3 to both sides. So x must be greater than 3. And x must also be greater than negative 3. So which one's the most restrictive? Well, this bottom one, x is greater than negative 3, means that have to be numbers to the right. But this one, x greater than 3, means that my numbers must be greater than 3, so I can't even include those. So my input to the function must be greater than 3. But what do we have as an answer? A negative number that's not greater than 3, so this ends up being no solution. Hope this was helpful, although it may have been long.